So today we are going to be in that packet that we gave you yesterday. We're going to take notes in there. We're going to do some problems in there, and then I'm going to give you lots of work time to work in there today. Okay. All right. You will also probably want to have out your formula or your identity sheet. Just have that handy so that you can have reference that back to and fro, backwards and forwards. Again, I remind you, not tomorrow Friday, but next week Friday, the 21st, is Battle Royale Friday, and we're going to have a formative that day. So the only classes that are affected by that is Schmelling's Friday morning class, mods 5 and 6. So if you are in that class and have open one of the other 4 classes that we have, by all means, feel free to come in and get that done. Or we ask that you take that to the Resource Center on Friday, just so that you're not letting it linger, so we can get it back to you the following Tuesday. Okay? All right? With me? Love it. Here we go. So yesterday we did this proof. We proved this is number 21, I believe, on your identities sheet. There it is underneath my backpack. Couldn't find the identity sheet. This is number 21 on your identity sheet. And basically what we said yesterday was we made this be, we said that sine of 2u is the sine of u plus the sine of u. Then we utilized the sum identity number 19, and we said that that is the sine of u cosine of u plus cosine of u sine of u. And then we said sine of u cosine of u is the same as cosine of u sine of u, because order doesn't matter. So then that said 2 sine of u cosine of u, and we had that one to use then. Then we asked you to finish off that worksheet, or that front side of that one. And so we said, well, we could make an identity for, this would be number 22, or the start of number 22 for that one. And so it's saying cosine of 2u is equal to cosine squared of u minus sine squared of u. Well, if I write this out as the cosine of u plus u, now I'm going to utilize number 18 on our identity sheet. That would be the cosine of u minus, because it's opposite, the SIGN is opposite, sine of u. So then that would become cosine squared of u minus sine squared of u. But because we're dealing with sine squareds and cosine squareds, we can remember from our hammer that cosine squared of t is equal to 1 minus sine squared of t. Which means that I can replace cosine squared of u with 1 minus sine squared of u. And then that simplifies to be the second one for a double angle cosine. We can also go back to what we had, where cosine of 2u was cosine squared of u minus sine squared of u. And then we can say here that now sine squared of t is equal to 1 minus cosine squared of t. And now I can replace that one and I can say sine squared now is 1 minus cosine squared, which would give me cosine squared of u minus 1 plus cosine squared of u, which gives me the third one in that one. And then lastly, we had the tangent, which was number 23. We can say that this is the tangent of u plus u, which if I utilize identity number 20, that would then be the tangent of u plus the tangent of u divided by 1 minus the tangent of u times the tangent of u, which is then going to be 2 tangents of u divided by 1 minus tangent squared of u. Okay? Now let's put those to work. That was what you guys were all supposed to be doing, or supposed to have done up to this point in time. So now let's put those to work on the next page. So if I wanted to solve something using a double angle or a half angle that we'll get to here later on, if I want to solve those, I'm going to utilize those identities that we now have. Okay? So sine of 2x, I get one choice for that, and that's going to be this 2 times the sine of x times the cosine of x. And that's going to equal the sine of x. Now, you want to divide by the sine of x, but we told you a long time ago in math that you can't divide by a factor. So instead, you're going to have to subtract the sine of x from both sides. That then is going to give you 2 sine of x cosine of x minus the sine of x equals 0. Then we can factor out a sine. Leaves me with 2 cosine of x minus 1. Then I can set my factors equal to 0. And I get to there. Where is sine equal to 0? 0 and pi. Where is cosine equaling 1/2? So all told, the 4 answers I get: 0, pi over 3, pi, and 5 pi over 3. Okay. I want to talk about number 5 a little bit here because it is quite intense. Okay? Okay? So if I have the sine of x plus the sine of 3x, I could write that instead as the sine of 2x plus x. Now I can do that because now I've got identities for both 2x and x, or the sine of 2x plus x. So now I'm going to utilize identity number 19. And so sine is going to be the sine of 2x times the cosine of x plus the cosine of 2x sine of x. All this still equal 0. Now I can go sine of 2x is 2 sine of x cosine of x. Try and keep the colors the same. Which cosine of 2x do you want to use? I got 3 choices. First one? Talk to me.
Where did the red cosine that you have up in that part, where did that come from?
Right there.
But there's one in the purple one.
Right. Hold on 1 second. Let me finish writing this and then I'll explain. Making this all up. Yep.
Yep, you are.
I even color-coded it for you. Okay, we'll start again. Ready? Okay. Sine of 3x became sine of 2x plus x, right? Okay. Pink became red utilizing identity number 19. Okay. First half of red became purple red, changing sine of 2x using number 21 into 2 sine of x cosine of x. Still have that extra red cosine of x. Then, now we'll switch hands. Cosine of 2x, you guys chose poorly. I'm choosing wisely. Went with 1 minus 2 sine squared times sine. What's up, Ben?
Oh, actually, never mind.
Okay. Do you see where I'm going now?
Yep.
Where am I going?
No,
Oh,
just go.
because I wanted to get all signs, right?
Yeah, you're good. Yep.
I wanted to get all signs. Yes? But I still got these 2 cosines here. What can I do with those 2 cosines? Both of them together, what do I get? What's cosine squared? 1 minus sine squared. So this becomes sine of x plus 2 sine of x times 1 minus sine squared of x plus 1 minus 2 sine squared of x sine of x equaling 0. And now it's all sine. It's a lot of signs. Ben, you look confused.
No.
Were you confused? Your face is telling me different.
Nah, I got it.
Okay. What's wrong?
Nothing.
We're having a different conversation. We're not talking about her starting in a bottom paper. Talk to me, Bennett!
Okay. Why did you choose to do 1 minus?
Now, do you understand why I chose the 1 minus 2 sine squared? Because now it's all sine squared. Yep. Or you could go like these guys over here. Just say, I'm just making this up. Yeah. Yeah. You know what? I ain't even finished this problem. We got this far. Let's go. Let's do this. Okay? Sine of x, right? Plus 2 sines of x minus 2 sine cubed of x. Yes. Plus sine of x minus 2 sine cubed of x. Yes? I'll pause for the cause. Okay. What can I combine? I get 4 sines of x, yes? 1, 2, 3, 4. Minus 4 sine cubes of x. What do you mean?
Well, I didn't know if you could just rewrite it so that it was like 4 sine cubed of x plus. Oh wait.
It would have to be 4 sine cubed of x minus
Minus
4 sines of x. Yep. Yep. If you wanted to. Yep. What can I factor out? I can factor out a 4 sine of x. What am I left with? 1 minus sine squared of x.
That equals cos. It must be
4 sine cosine squared, if we wanted to. But now we could make this be 4 sine of x equals 0. So that's where sine is equal to 0. We could make this be 1 minus sine squared of x equals 0. So that's plus or minus 1 is sine. Okay? Where is sine 0? 0 and pi. Where is sine positive 1? Yeah, but where is it positive? Pi over 2. Where is it negative? There's your answers. But it's fun. It is. Hey, we'll come back to those in a minute. If you go to the next page, if you go to page 3, yes. We're going to talk a little bit about half angles. Okay? Now, specifically, I want to talk about the half angle identities, and I want to talk specifically about these 3 plus or minus signs there. Okay? Those plus or minus signs don't show up in your answer. It's either going to be positive or it's going to be negative. And that depends on where your angle is in which quadrant. Okay? Remember, in quadrant number 1, sine, cosine, and tangent are all positive. In quadrant number 2, only sine is positive. The other two are negative. In quadrant number 3, only tangent is positive. The other two are negative. And in quadrant 4, only cosine is positive. The other two are negative. Okay? I say that because if you give me here, like for sine of 15 degrees, if you give me plus or minus whatever it is, we're going to mark it wrong because it's only positive, because 15 degrees is in quadrant number 1, sine is positive in quadrant number 1. Everybody understand what I mean by that? Okay? All right? So let's try one here. Schmeling said that we were supposed to do number 2, but he's not here, so I'm doing number 1. Okay? Calling an audible. All right? So, the sine of 15 degrees is the sine of 30 degrees divided by 2. Do we agree with that? Yeah. 15 degrees is in quadrant number 1, so I am going to have a positive, not positive or negative, just positive sine value there. And I'm going to utilize here now identity number 24. That's going to be 1 minus the cosine of 30 degrees, all divided by 2. Okay? What is the cosine at 30 degrees? Cosine at 30? Root 3 over 2? Yes? Would you agree that I could do this right there? Yeah? Why am I doing that, Ava? Common denominators, right? Yeah. So then this becomes 2 minus the square root of 3 all over 2. Still all over 2. Yes? Would you agree that that is really... Oops, I should put this in the right order. Pardon me. I apologize. Clearly, I blame myself. Would you agree then that this is 2 minus the square root of 3 all over 2 times 1/2? What did I do? Keep change flipped it, right? Okay? 2 is, dividing by 2 is the same as multiplying by 1/2. Agree with me so far? Okay? Agree with that? Yes? Okay. When I'm taking a square root of a fraction, what do I really do? If I'm taking the square root of a fraction, what am I really doing? Square, yeah, I can square root them separately, right? Okay? So this is really the square root of 2 minus the square root of 3 all over the square root of 4. Yes? What's the square root of 4? 2. Now, here is what I'm going to tell you to do. Because we're dividing by 2, right? Because the square root of 4 is 2. I am going to strongly suggest that you write this answer like that. Here's why. Okay? If you try and write it like this, other than the fact that, yes, we have radicals inside of radicals, okay? We're not scared of that, okay? If you write it like this, we don't know where your fraction stops. If it's all over 2, if the over 2 is inside the radical, or anything like that. So to avoid that confusion, because, and I say this because we have done this for the last 5 years, we mark this wrong. If we don't see it with gusto, for lack of a better word, with clarity, if you will, we will mark it wrong. Okay? Right? To avoid all of that, write it like this. And then there's zero confusion. Okay? With me? Let's skip to number 5. Tangent of 7 pi over 12. Okay?
Why are there so many options?
So many options for tangent.
Pick one.
Grrr!
Can't you just pick one you want to do?
Yeah. First off, do you agree with me that 7 pi over 12 is 7 pi over 6 divided by 2? I know. Now, on 26, I've got 3 choices. Yes? Which one are you definitely, probably never, ever, ever going to choose? The last one, right? Why bring radicals into it if you don't have to? Okay? I get it. 100% I get it. Okay? I will tell you, though, on this particular one, if you were to choose that third option, would it be a positive radical or would it be a negative radical? Where is 7 pi over 12? No, you don't need a calculator to use this. Where is 7 pi over 12? It's in quadrant 2, right? 6 pi over 12 is pi over 2. 12 pi over 12 is pi. So it's in quadrant number 2. What is tangent in quadrant number 2? Negative. So if you chose that third option, you would have to put a negative sign out in front of your radical. And only a negative sign. Okay? We're not choosing that option. We're smarter than that. Which option should we choose? You got a choice. Be smart. Which one do you want to choose? You?
Second one.
Why would we choose the second one? But what's better about the second one than the first one?
Oh, there's no.
The denominator. The denominator is just sign. It's not an adding or subtracting thing. Okay? It's just sign. So I'm going to say here then that this tangent is equal to 1 minus the cosine of 7 pi over 6 all divided by the sine at 7 pi over 6. Yes? Do I not need the what?
So you don't need the divided by 2 for any of that?
No, because it's the identity is u divided by 2. So u is 7 pi over 6.
Okay.
Okay. What is the cosine at 7 pi over 6?
Negative 3 over 2.
What is the sine at 7 pi over 6? Negative 1/2. What can we do here right from the jump? Keep, change, flip it. So this would become 1 plus the square root of 3 over 2 times negative 2 over 1. You concur with that? Yeah? Which would be then negative 2 minus the square root of 3.
Where's the 1? Oh.
What do you mean? Distribute in the 2.
Oh, yeah.
Okay? I get it. I get it. I understand.
Like 1 or 0 is really nice.
And then you got, now we're putting radicals inside of radicals. Yeah. Good times. Okay? What we would like you to do now is, before you come to class tomorrow, I want the rest of that white packet completed. Okay? Yep. Before you come to class tomorrow, rest of the white packet done.
That's just that. Even the back.